George is towing his trailer behind his car, and the total mass of the car and trailer is 2.2 tons or 2,200 kilograms. At a set of lights, George brakes and brings the car and trailer to a rest. The following graph shows the force versus time for this action. So, we see that at 8 seconds, the point where George begins braking, the force is 6,000 newtons. Now, the area under the graph is Ft, which is equal to the impulse, which is equal to the change of momentum, or delta P. Now, we know that P equals mv, and we know that delta P equals P final minus P initial. So, we know that P initial is 0, and P final therefore has to be mv. Now, so we know the delta P is simply mv in this case. So, first of all, we work out the impulse, which is the F force times time, which turns out to be 6,000 times 8, which is 48,000. Now, we know the delta P is 48,000, so we put it into the equation of 48,000 equals m times v. Now we know that m is 2,200, so we get 48,000 equals 2,200 times v. We divide 48,000 by 2,200, and we get v equals 21.82 meters per second. That's how fast the car was going at the point of braking. Christine is bouncing on her trampoline. At her maximum bounce height, the bottom of her feet are 1.5 meters above the level of the unstretched trampoline surface. At the lowest point of her bounce, the bottom of her feet are 0.5 meters below the unstretched level of the trampoline surface. She also weighs 48 kilograms. So, from all this, we know that it's an energy question, because at the bottom of her jump, she has elastic potential energy, which is converted to gravitational potential energy at the top of her jump. Now, this means we can do an energy equivalence showing 1/2 kx squared equals mgh. Now, we sub in the numbers, 1.5 meters for the h value, 48 kilograms for the mass, 9.8 for the g value, and 0.4 for the x value. All of this we get from her various positions in and around the trampoline. Now, then we solve for k, showing that k equals 705.6 times 2 divided by 0.16, and finally showing that this equals that the k value equals 8,820 Newton meters.